which is on many elements multimodal. It's about information flows linked, for instance, to the freight or to the passengers, which moves between modes. It's about open data, it's about non-commercially sensitive data, then it's also about integrated network-related data more closely. It can be monomodal. So far it's mostly monomodal. One of our efforts is to make it becoming more multimodal. And then we have big data concerning the performance of a line, in terms of passengers, in terms of whatever we assume, including vibration, to assume the state of to detect the state of the infrastructure, sensors on smart trains in order to identify the condition of transport, and also to track and trace within a specific monomodal journey goods, to analyze whether certain conditions were fulfilled, and to provide information to logistic operators. So we come into monomodal ICT. This is also part of digitalization, and then we have the typical ones that are the critical applications, and I'm quite glad to have heard this distinction made by the technicians very well beforehand, which are within railways and which are within dedicated systems. Safety and interoperability being the critical ones. So this is crucial. As we heard before, we have security-related topics which lead to important information flows that are not critical, meaning you can have CCTV, you can have a large amount of data, but it's not something that has to be kept and managed within the system in real time. We can go on the following one. So we have two main elements for us. In the following slide, you can see, touch upon the first one. We have two, of course, we transport different things. We have rail freight and rail passenger. Then we have some enablers which we'll touch upon afterwards. So rail freight transport has a basis which is a specific standard for interoperability on telematic application for freights, and we got the agency which is present can tell you more about this. I won't talk here about our main stakeholders, but as you all know, we have a specific European Union Agency for Railways, whose acronym is still ERA, and we have joint undertakings that have already been talking quite some time intensively today, which is Shift to Rail, where all the sector is involved in deploying innovative solutions for specific elements, and notably for digitalization. So we have a standard which aims at ensuring a good information flows between networks when you have a journey which cross different networks, when a railway undertaking wants to pass through several member states, but also sees the interface with all the logistics and the delivery of a single good into a wagon, the formation of a train, and the flow of the train throughout several infrastructure managers, together with the possibility of keeping and tracing not only the position but also all the contractual documents which are linked to the transport of the good, in order to have a proper tracking, tracing, but also a chain of liabilities throughout it. And also, one of the aspects is something where rail freight corridors have been working quite a lot. One of the nightmares for logistic operators dealing with railways is knowing in advance when the train is arriving, not just because they get out of the window and they see it coming. So expected time of arrivals. But if we can go to the following ones. I'm talking very generally about politics, transport policies, and the white paper. Next slide, thank you. The point is that, what is the perspective anyhow for us? What is the evolution, which is already foreseen by the white paper in 2011? The evolution is that we have launched an initiative linked to e-freight, which is the logistics single window, which means that we would like to simplify, to cut the red tape, which is one of the main causes for fragmentation of the single transport area, and to have the possibility of having an information flow, which can be open or not open when commercial, but visible to all the dedicated operators, that starts, as usual, from the old concept of the maritime single windows, because 75% of a import and export comes from the sea, and 40% of internal flows as well, and then provides all this information, including condition for transport of dangerous goods and so on and so forth, phytosanitary products, packing list, to all the other operators for inland transport, including railways. This is a model that has already been the one you see on the left-hand side, developed by Portuguese ports with Spanish logistic platforms, and is working now. So that's something possible. The point is how to make it, to have railways fitting into it easily and swiftly, to come to something which is not visible for the final user. It's just that railways provide the capacity in terms of capacity of transport, and railway undertakings provides the actual capacity allocation on a train, but that's not necessarily a complication for the final customer. Simply, it all fits into a logistic chain in which all documents are already available online, thus maximizing the potential for railways. And we can go to the next one. The other main branch, as you all know, is of course rail passengers. We have as well a specific ambition which is being developed that is more on the process now. This is a technical standards for the interoperability and telematics application for passengers, WTSI, on which the main topics is sharing information between actors, real-time information, price information, etc., and sharing, of course, providing the opportunity to have a proper ticketing with third-party vendors, etc. It's partially linked to open data policy. It's linked also to a dream which is through ticketing, meaning I have a ticket for going from A to B, and I can take whatever trains runs to it. And there's a specific group which is leading, which includes some of the main stakeholders that are working towards a full service model and other development in order to bring it about. But again, this is a part which is still wrapped into the railways, and railways have more to gain from integration than any other mode of transport, because of the massive amount of commuters and of intercity flows they manage, and of course, if they can provide it in an integrated way from door to door, they are clearly winning competition over any other mode of transport. So the ambition, and next slide, is to evolve considering, this is just, okay, a preliminary stage, but we see the first movement in this direction, to evolve it towards providers of mobility as a service. Meaning that if I can go from Brussels to whatever neighboring town, or Paris, London, whatever, but can also, Paris and London, I can basically only commute by train. But if I take something where I have competition with other modes of transport, but train can offer me a package including, I don't know, a one-way car sharing model or whatever, and we see the first cooperation which are being triggered now by, for instance, SNCF, Petroatp, and BlaBlaCar, which are quite interesting, and Transdev. If I can have a total service, then in this case, of course, the model share and the potential of railways is enhanced to the maximum. So the idea is how we can have railways into this puzzle, which has lots to do with, of course, the multimodal information system and so on and so forth. You can go on the next one. But of course, telematics has a lot to do with, we are well aware of the fact that, coming back to railways, that there are major improvement in efficiency in railway systems through telematics. Of course, the RTMS is one of the main objectives because it can deliver in terms of safety to the maximum level. It can deliver in terms of capacity, and in its evolutions up to level 3, this element will be magnified. We already see major cases in which the RTMS deployment is considered as an alternative to major infrastructure deployment, which means saving tens of billions of euros due to the increasing capacity. We can go faster, of course, with the RTMS as well, keeping higher standard, and we saw it with level 2 in the Spanish network when it works. We have ATO, meaning, of course, we are waiting. We have already cases since several years of network-specific automated train operations, but the sector is rolling out with enhanced grades of automations, models for automated train operations, which can provide better energy efficiency, provide an even enhanced use of the capacity. If you basically exploit all the possibility of headways, etc., you coincide in your speed profile with what is offered by the ERTMS capacity. But also, in future, we hope that automated train operations can bring about lots about operational interoperability, meaning that we will not, this can be a disruptive innovation that can overcome all those barriers which are affecting railways, such as the language of drivers, the number of drivers, tail lights, and so on and so forth, and who has to change them, and all these other elements which are linked to a 19th century rather than 20th century mentality and rules. And if inframanagers accept to have automated trains running, this can be a major breakthrough for facing these elements. Then, of course, this is mostly Shift to Rail IP2, Innovation Program 2. There's a modular innovation being brought about on the European Train Control System, ETCS, which is mainly named ERTMS, but it's not a traffic management system. Yes, the idea is to have a holistic system that, using enhanced communications, etc., provides also information up to the other operators, but allows to have a real train traffic management system integrated with the signaling, benefiting from an enhanced onboard intelligence, which is already needed for level 2, when it will be the train that communicate with the other trains without having a fixed block position speed, which might lead to major savings on trackside, not on onboard, I fear. And again, this will provide more capacity, as we said, and also a better speed profile, depending on if you want to save more energy or if you want to go faster, of course, which change dramatically the behavior. And then we have everything which concerns big data. We already see smart trains operating. We already see an enhanced use of logistic operations, which benefit not only from intelligence on the wagons, but an optimized allocation between a network of logistic centers, thanks to increased information available. And but of course, big data is important also for predictive maintenance. Some suppliers expect to squeeze actually defaults from 80 to 90% thanks to predictive maintenance, detecting with several sensors the main parameters along the loco. And I think we'll hear something about it afterwards. So this is another element which can improve dramatically the efficiency within the mode of transport. But we can go to the following one. All this will require, and I think it has already been said today, sorry for repeating it, we are well aware in terms of commission, we require capacity in terms of telecom communication. It will also require finding a new system, identifying and agreeing on a new system post GSMR, because so far we have GSMR and with baseline 3 released to GPRS, which is already more efficient in terms of data package, but this will not stay forever. It's relatively obsolete in terms of telecom. Will stay for another 15 years maximum, we think. And some IMs tell us that 2033 is guaranteed for them. We hope so. But we have to roll out a new system now, and we have to identify and to satisfy all the spectrum needs for them. And that's something we have to take care now. Of course, we have to consider that whatever system we choose starting from LTE, there will be an increase in capacity, meaning capacity per megahertz in terms of number of voice communication or data communication will increase within 5 and 10 times at least. If you go for 5G, it's even more, even keeping the actual infrastructure. But another point is that, okay, we have anyhow capacity now is will be constrained because now we have 2 times 4 megahertz, which are harmonized for GSMR. We have an option which is used by some member states, a minority actually, of additional 2 times 3 megahertz, and but that's not harmonized. And in the future, we will have to accommodate 2 different telecom systems because it's quite unlikely. It's not the official Commission position, but I deem it quite unlikely to have an overnight shift between one system and the other. That would imply having to equip all the rolling stock of a continent beforehand and then agreeing on the data. Therefore, it will be capacity will be constrained in some nodes and some networks, and we have to make a distinction. That's why it is very important to clarify when we see all the potentials that are available in terms of ICT and transport, between what is really a critical application, what is not critical, what has to go on a specific, without any latency, or very low latency, on a specific, harmonized, and dedicated spectrum band, and what can go on other application, what can be sent every minute or so. I think big data in general will not be critical, in order to decide what to accommodate in the available capacity. Where we still have anyhow to come up with fully harmonized solutions for the future. And okay, we have to go on the... So as you might know now, it's not likely they will have a single system accommodating all the potential of ICT, but for critical interoperability and safety-related applications, yes, now there's a proposal on the table, which is the so-called squeeze option, debated by Radio Spectrum Committee, and which is to have a harmonized 2 times 4 plus 1.4 megahertz. There are other options for going up to 7, 2 times 4 plus 3 megahertz. And as we said, this is something where we have to accommodate a capacity, where we have to accommodate a transition from now to the future system, which will be around 2030, when most of the member states will have the new system in place, or entirely in place, at the place of GSMR. Then we will have an apparent excess of capacity, which we might well think about what to use. Another point is that, meanwhile, it's not just this capacity. We have to be sure that this capacity is protected from interference. And one of the constraints, which I already mentioned, is that if we don't have it in an harmonized spectrum band, we risk harming interoperability, or we increase again the cost of on-board unit. And then something which has been quoted today, and it's quite correct in the last slide, which is all this anyhow will imply more and more IP-based solutions along the tracks as well, and on trains, and more automation, so automated response to the messages, which are already by far generated by the systems. Therefore, there will be lots of information up in the cloud, and we need a systemic supervision and cybersecurity protection. Rather than having everything standardized, I believe that we need to have, of course, safe components. We need to learn a lot, so to exchange a lot of information with other sectors which have gone beyond, and other sectors which have similar problems, such as air transport. And we need to ensure that there's a systemic approach in place to appraise the risk, to mitigate the risk, and to come with an acceptable level of protection, of detection and protection against cyber attacks. Considering that anyhow we will need a holistic vision, as the ones we witnessed before, between physical security and cyber security, because the two elements will be interlinked and interconnected. Of course, cyber attack can prevent the detection of physical attacks and vice versa. So this is something where we need to work upon, considering all the potential lessons to be learned from other transport modes. So thanks a lot, and I'm here for any specific question. This was a very high level, let's say, policy overview and not a detailed technical ones, but this was more the role of the first panel, where I was supposed to be involved. Thank you.